So hello everyone. This is R Sasikumar, Professor, Department of Computer Science and Engineering from RMDEC Engineering College. So today we are going to discuss about need for process synchronization in operating system concept. So before we move on to this topic, we should know what is called a process synchronization. Actually, the process synchronization, it refers to the coordination of multiple cooperating process or threads. Right? Suppose whenever we have more number of process or whenever we have a more number of thread, what is called a thread is nothing but what one small task. Okay, so whenever we have multiple process or multiple thread, then we should ensure orderly and consistent access to shared data and resources. So the process synchronization, it should refer the coordination of multiple cooperating process or multiple thread to ensure orderly and consistent access to shared data and resources. So what is the need of process synchronization? It preventing data corruption and race condition. So data will not be lost and the race condition will be avoided with the help of process synchronization. That's why we move on to process synchronization, and it is crucial for maintaining data integrity and managing resource allocation fairly. Okay, we have to allocate all the resources fairly. That is a very big task. So that will be done with the help of process synchronization. And so why is process synchronization is needed means what? We have to maintain the data consistency, and we have to allocate a resource fairly, resource management, and execute all the process in order wise. That's why we need process synchronization. And what are the important key concept of process synchronization? The critical section, mutual exclusion, progress, bounded waiting. Okay, and what are the common problems for process synchronization means what? The first important problem is what? A producer consumer problem and reader writer problem, Peterson algorithm, semaphore problem. So in this video, we will see that producer consumer problem along with race conditions. So there are two processes. One is called independent process and another one is called what? Cooperating process. So what is called independent process means what? If the execution of the process is not affected by or does not affect the execution of another process, then the process is called what? Independent. So one process output will not affect the another process, that is called what? Independent process. Everything will be executed independently. And what is called a cooperating process means what? If the execution of the process is affected by other process, that is called what? A cooperating process. It is not possible to complete all the tasks successfully. That is called what? A cooperating process, because the execution of one process is affected by the execution of another process. Okay. And I told already, right? There are three important problems available: producer consumer problem, reader writers problem, semaphore problems. Right? So in this example, we see that producer consumer problem. So what is called a producer process? So this is a pseudocode of a producer process. While of true, produce an item in the next produced. While of counter equal to buffer size. So our counter which is equal to buffer size means what? Then the maximum size is filled. So we have to do nothing. So then otherwise what? Buffer in equal to next producer. So what is the next item? So one producer at a time can produce 10 cars means what? That is the maximum limit per day or per week or per month. Okay, if the counter which is reached that buffer size now, then we have to stop the process. Otherwise what? We have to produce the next item. So buffer of in equal to next produced. Then increment the counter variable in equal to in plus 1 divided by the buffer size, the maximum buffer size. Then the increment the counter plus. Likewise, we have to do we have to produce all the process one by one. So the counter is nothing but what? A counter variable. Always the counter variable, we have to ensure that whether the counter variable which is equal to buffer size or not. Okay, if it is equal to buffer size, na, then you have to stop the process. Otherwise, what? You can produce n number of items continuously and increment the counter variable as early. Okay, then we have to ensure that whether the counter equal to buffer size. This is called what? A producer process. And the consumer process, likewise, like a producer process, the same thing. And while of true, while counter equal to 0, then you have to do nothing. Otherwise, what next consumed equal to buffer of out. So out equal to once one item is retrieved from that warehouse, right? Then you have to reduce the process by one. So counter value will be decremented by one, and we should calculate that how many items can be retrieved. So that is that out value mod buffer size. So what about that buffer size? The maximum is 10. Na? If you take one process at a time, na, then how many process left over? So you should that out value mod divided by mod by buffer size. Then easily you can find out how many items available in that warehouse, and then how many items we can sold. So likewise, and once the item is retrieved from that warehouse, na, then you have to decrement the counter variable and again ensure that whether the counter equal to 0. Once the counter variable equal to 0 means what, then you stop the process. This is the way to consume the item one by one. And the next, what is the main need of process synchronization, which is used to avoid the race condition problem. So, what is called race condition? So, a race condition occurs when multiple processes or multiple threads access and modify shared data concurrently. And the final outcome depends on the unpredictable order in which process execute. Okay, so race condition means what? Whenever we have more number of process or whenever we have more number of threads, then if all the processes are sharing the same data, definitely what the race conditions will occur, because which process is currently executing. It is very difficult to find out which process is currently executing. That problem is called what, race conditions. With the help of a producer and consumer problem, we have the same example. So the counter plus plus means what, could be implemented as register 1 equal to initially counter. So the initial counter variable will be assigned to register 1. Then once the process is incremented, na, then the register 1 equal to register plus 1 and the counter equal to register 1. So what is called a counter? This is what retrieve the item, consumer process. So counter minus minus means what, could be implemented as register 2 equal to counter, and once the item is retrieved from the warehouse, na, then the process item will be reduced. So register 2 equal to register 2 minus 1 and counter equal to register 2. So consider this execution interleaving with the count equal to 5. Initially, what is the value of counter? 5. So now what is the race condition? So in task 0, S naught, the producer execute register 1 equal to counter. That is the first process, register 1 equal to counter. So what is the counter variable? Already 5. So now register 1 which contains what? 5. Then the producer. So producer execute register 1 equal to register 1 plus 1. So what is the value of register 1? Already 5. So 5 plus 1, 6. Then the consumer execute register 2. Register 2 equal to counter. What is the value of counter initially? 5. So now register 2 equal to 5. Then already one item will be retrieved. So we have to decrement. So register 2 equal to register 2 minus 1. So the counter variable will not be modified. If you modify it, it is very difficult to find out. So that's why we have to move that value into temporary register. So the register 2 minus 1. Now the register 2 is nothing but what? 4. The producer execute a counter 1 equal to register 1. So what is called a register 1? Already 6. Then the consumer execute counter 2 equal to register 2. What is the value of register 2? 4. So this is the way to avoid a race condition problem. So that is the need for process synchronization. I hope you understand this concept. Thank you.